Hello everyone. In our previous class, we have discussed about Dalton's atomic theory. In that, we have discussed that the Dalton was the first to postulate theory regarding the atoms. That atom is the smallest particle. It is indivisible. It is non-destructible, non-cuttable. Atom is the basis of all chemical reactions. Atoms participate in chemical reaction. Atoms combine to form molecules. All these were discussed in our previous chapter very clearly, very in descriptive way, in detail. We have discussed in our previous chapter. Now, after the discovery and after studying the drawbacks of Dalton's atomic theory, that atom is not remain indivisible, that atom, after the discovery of isotopes, that the atoms of the same elements are different, after the discovery of isobars, means the atoms of different elements have same property like the atomic mass, whatever it is. And after the discovery of electron, proton, especially by the discovery of J.J. Thomson, that atom is, or we can say that after the discovery of subatomic particles, atoms remain no more non-divisible, indivisible. So that here in this topic, in this chapter, in this lecture, we will discuss about the subatomic particles. That is, what are the subatomic particles? So subatomic particles are the particles which constitute atom, which makes atom, जो atom को बनाते हैं. So the subatomic particles are like electrons, protons, neutrons. These are the basic three particles that constitute an atom. There are also different particles, positron, neutron, neutrino, all these are the also the particles that is present inside an atom. So all these particles combine together to constitute an atom. So here in this section we will study about the structure of atom, what is the structure of an atom, what it looks like. But before going further, before discussing about the structure of atom, first of all we will discuss about the subatomic particles, that what is this proton, neutron, who discovered them, when it was discovered, what is their nature, what is their mass, means about their properties in detail. After knowing about these three particles, then only we are able to describe the structure of an atom. So, one thing we have discussed, or we know that electrically an atom is neutral. Electrically an atom is neutral. It means in an atom number of electron is equal to number of proton. Electron having negative charge and proton having positive charge. Electron have negative charge, proton have positive charge. Neutron neutral means no charge. Neutron has no charge. There is no any charge on neutron. It is electrically neutral. So, in the sense when an atom has equal number of electron and equal number of proton, it means the atom will be neutral. There will be no any charge on that atom. And in our previous class we have discussed that the atom or the group of atom which have a charge, it will remain, it will not consider an atom. If an atom has charge, it will become ion. And there are two types of ions, positive ion and negative ions. So all these things we have discussed earlier in our previous chapter. Here in this chapter we will discuss about subatomic particles like the electron, proton and neutron, and the structure of atom. So before discussing it, we will learn about the discoveries of electron, proton, neutron. Discovery of electron is also known as cathode rays. So it is also known as discovery of cathode rays. Proton is known as canal rays, anode rays. So in detail we will discuss about all these things. Today we will discuss about discovery of electrons, that is cathode rays. So we will see here discuss this discovery of electron with schematic diagram of cathode rays experiment that was produced by discharge tube. The cathode rays experiment was done by J.J. Thomson in 1897, and for this experiment he has used a discharge tube. What is a discharge tube? A discharge tube is a glass tube sealed at both the ends that have two electrodes, positive electrode and negative electrode, that is cathode and anode. It has a gas inside it, and the pressure of gas is very low, and the voltage that is supplied between the two terminals of the discharge tube is very high. So under the application of high voltage and low pressure, we have observed that Thomson has observed the sun rays originate from cathode and moves toward the positive terminal. So before moving further, let us discuss about discharge tube. So just wait for a minute. Now, this is the diagram of discharge tube made by J.J. Thomson, that is he used it in J.J. Thomson 1897 discovered electron by performing discharge tube experiment. Discharge tube is a glass tube which consists of two electrodes. That one is negative terminal, this is cathode. Here pump, vacuum pump to reduce pressure inside the discharge tube. This vacuum pump is used to reduce pressure inside the discharge tube. Here this one is anode, this one is the power source to provide high voltage. This one is, these are cathode rays. So when very high voltage is applied between these two terminals of discharge tube, a rays originates from cathode and it moves toward the positive terminal, that is anode. These rays consist of negatively charged particles. It was proved that the rays move toward the positive terminal, toward the opposite electrode. That's why it is believed that these rays consist of negatively charged particles, that is electrons. When these rays reach toward the opposite terminal, means toward the anode, so these were called cathode rays, and these cathode rays consist of negatively charged particles, and which particles are known as electrons, named as electrons by J.J. Thomson later on after studying its property. Now, J.J. Thomson performed the Goldstein performed this experiment. Rather, Thomson named it electron, and Millikan find the value of charge on an electron that is equals to minus 1.6 into 10 to the power minus 90 coulomb. This was the charge of an electron. Take Thomson calculate charge to mass ratio of electron that is same for the electrons of all the types of gases, all the types of different type, all the substance, whatever the substance are present here, all the substance means the charge to mass ratio for an electron is same for every substance. Charge to mass ratio, that is E by M. Charge to mass ratio that was calculated by Thomson first of all for electron, and that was equal to, for electron it was equal to 1.76 into 10 to the power 11, 10 to the power 11 coulomb per kilogram. This was the charge to mass ratio for electrons of all the types of matter, doesn't matter, it means the charge to mass ratio E by M of electrons is independent of the nature of gas used in cathode rays. कैथोड रेज में कौन सी गैस यूज की है इससे कोई मतलब नहीं है. Charge to mass ratio is same for all the types of electron, means electrons from different types of atom, whatever it is, from hydrogen gas or oxygen gas or neon or carbon, whatever it is, carbon dioxide, whatever the gas is used, means the charge to mass ratio will be same for electrons of all the substances. Okay, Millikan find the mass of a charge on an electron, so that is charge on an electron that is equal to minus 1.6 into 10 to the power 19 coulomb, and the electron is donated by a symbol that is E. Wherever it is written as E. So these were the experiments that were performed by J.J. Thomson to find out, to produce, to discover electron. Later on in the next class we will discuss about the properties of cathode rays and the discovery of proton, that is anode rays. Till then, go through the topic, revise it. Have a nice day. Thank you.